What if the absolute most powerful disinfectant in your kitchen, like one that can totally obliterate salmonella and norovirus in just seconds, is literally the exact same liquid that's rushing through your veins right now?
It's wild to think about, right? It really just completely flips how we think about cleaning. Because, I mean, we're so conditioned to believe that wiping out bacteria requires, carpet bombing our homes with these harsh synthetic
Yeah,
chemicals.
exactly. You open that cabinet under the sink, and it's basically a hazardous waste site in there.
Oh, totally.
Just rows of bottles with skull and crossbones warnings.
Mhm.
You've got bleach, ammonia, fumes that literally make your eyes water when you use them.
Right. And we've been trained to think that if a cleaner doesn't blunt our lungs just a little bit, then it's not actually doing its job.
Yes, like it has to hurt to work. But when you look at biology, and specifically the human immune system, that harsh, burning chemical approach suddenly seems really incredibly primitive.
It is. I mean, it's the definition of chemical overkill. Biology has had millions of years to perfect these microscopic defense mechanisms that are just far more elegant and, frankly, a lot more ruthless than anything we traditionally buy in a plastic jug.
Which perfectly brings us to the mission of today's deep dive.
Hmm.
We're looking at a comprehensive guide from Era Organics, and this was written by Nikki Chase back in April 2026.
Right.
And it's all about hypochlorous acid cleaning spray, or HOCl for short. And the claim here is just staggering.
It really is.
This scientifically backed liquid says it can replace your bleach, your ammonia, your glass cleaner, your bathroom scrub, all of it, all while remaining completely safe to spray directly on the exact surfaces where you prepare your food.
Yeah, which sounds impossible.
Exactly. So we really need to figure out if this is actually the ultimate cleaning hack for your home or if it's just, way too good to be true.
And in an era where you walk down the cleaning aisle and you're just bombarded with endless products and super confusing labels, understanding the fundamental chemistry behind what you actually bring into your home is crucial.
Definitely.
We don't just need to know that a cleaner supposedly works, right? We need to understand how it interacts with our physical environment on a microscopic molecular level. That's really how you take actual control of your home's safety.
Okay, so let's unpack this because before we suggest that anyone just goes and throws away all their traditional cleaners,
Yeah,
we need to understand the weapon we're dealing with here.
absolutely.
If traditional bleach is like a loud wrecking ball tearing down a forest just to get rid of a few weeds, HOCl seems more like introducing a highly trained spy or a ninja. The text actually points out this really specific characteristic. It says HOCl has a neutral electrical charge.
Right.
Why does the electrical charge of a kitchen spray even matter?
Well, what's fascinating here is that the charge determines whether the cleaner can actually reach its target in the first place. You have to think about the cellular mechanics of a bacterial cell.
Okay.
So, most bacteria have a negatively charged cell wall. If you spray a negatively charged chemical cleaner onto that bacteria, you get magnetic repulsion.
Wait, really? Like two magnets?
Exactly like that. It's just
Okay.
physics. It's like trying to force the negative poles of two magnets together. They physically push away from each other.
Wow, so your traditional cleaner is actually fighting a literal magnetic force field just to make contact with the bacteria.
Precisely. A lot of the chemical energy is just wasted trying to overcome that repulsion. But HOCl has a neutral charge.
Ah, I see.
Yeah, so it doesn't experience that magnetic pushback at all. It basically acts like a microscopic ghost. It effortlessly slips right past the bacteria's external electrical defenses, completely undetected.
That is so cool.
Right. And once it penetrates the cell wall and actually gets inside, it initiates this process called rapid oxidation.
Okay, let's break down rapid oxidation because that sounds like a very dense textbook term. What is actually physically happening to the bacteria inside?
So imagine the bacteria's internal proteins are built out of like thousands of precisely balanced microscopic Lego blocks.
Okay, I'm with you.
Oxidation is the process of aggressively stealing the electrons that are holding those blocks together.
Yeah.
So HOCl essentially rips the foundational pieces right out of the microbe's internal structure.
Oh, wow.
Yeah, the pathogen's proteins destabilize and just collapse. The bacteria is completely destroyed from the inside out almost instantly.
That is ruthless. And the really mind-blowing part of this source material is that this isn't some weird alien chemical synthesized in a corporate lab somewhere.
Not at all.
The chemical formula for hypochlorous acid perfectly mirrors the exact substance produced by human white blood cells. Like when you get a paper cut, your body sends these specialized white blood cells, neutrophils, I think.
Yep, neutrophils.
Right, to the site. They engulf the invading bacteria and then just flood them with HOCl. You are literally constantly manufacturing this stuff inside your own body just to stay alive.
Which perfectly explains why the ingredient list on a bottle of HOCl is so deceptively simple. You aren't going to see a massive paragraph of, unpronounceable industrial solvents.
Right.
You essentially have two things. You have purified water, which just acts as the carrier, and salt, which provides the chloride ion.
Okay. If it's just salt and water, I know exactly what everyone listening is thinking right
Oh,
now.
I know too.
Can I just, mix some regular Morton table salt into a spray bottle of tap water and just start sanitizing my kitchen?
You definitely cannot. Yeah, salt water won't clean anything but a wound, and honestly, even then, not very well.
Right, okay.
The missing ingredient here, the real catalyst, is electricity. Manufacturers take a highly purified brine solution and run a very specific electrical current through it in a process called electrolysis.
So they're literally just shocking the salt water.
Exactly. You have this chamber with a positive and a negative electrode, and when the current passes through the brine, the energy physically tears the salt and water molecules apart.
Wow.
Yeah, it forces the sodium, the chloride, the hydrogen, and the oxygen to entirely rearrange themselves. That electrochemical reaction takes basic inert natural elements and supercharges them. It locks them into the active molecular structure of hypochlorous acid.
All right, so we've established we have this supercharged, biologically inspired cellular assassin in a bottle.
Yes.
But moving from the laboratory to the physical reality of a messy kitchen, how do you actually deploy it? Because reading through this guide, I immediately thought about Sunday mornings.
No, yeah.
Can I just spray this stuff all over a kitchen island that's completely covered in, dried toast crumbs, spilled coffee, maybe some bacon grease, and then just walk away assuming everything is totally sanitized?
No. And that is a vital distinction that catches a lot of people off guard. HOCl is a chemical neutralizer.
Yeah.
It is not a physical shovel. It absolutely requires direct contact with the microorganisms it's trying to target.
So the bacon grease is actually protecting the bacteria.
Exactly. Physical debris like your toast crumbs, oils, or heavy food soils acts as a microscopic bunker for pathogens. The bacteria just hide underneath and inside that debris where the liquid can't physically reach them.
Oh, I see.
So the ironclad rule of engagement here is you must remove the physical dirt first, wipe away the crumbs, clean up the heavy grease.
Right.
Then you apply the HOCl spray until the surface is visibly wet. Saturation is absolutely key. You are basically flooding the microscopic landscape.
Okay, and the guide also breaks down the actual timelines for that flooding. And it depends entirely on what level of clean you're actually trying to achieve.
Right.
If you just want to sanitize, which the industry defines as eliminating 99.999% of surface bacteria, you really only need to leave the surface wet for about 30 seconds.
Which is pretty fast.
Yeah. That seems incredibly practical for things you touch constantly, like your phone screen, your computer keyboard, the TV remote.
Right. But if you are aiming for full disinfection, which is a much stricter medical grade standard designed to wipe out highly resilient pathogens, the source says you need to leave the surface wet for a full 10 minutes.
10 minutes.
Yeah, that 10-minute window gives the HOCl the sustained time it really requires to systematically break down the thickest, toughest bacterial cell walls.
Okay, but let's talk about the reality of that 10-minute rule.
Yeah.
Because frankly, nobody is standing at their kitchen counter for 10 straight minutes waiting to wipe it down before they start cooking dinner.
No, of course not.
How does a 10-minute wet time actually fit into a normal routine? Am I just supposed to stand there holding a paper towel?
You don't have to stand guard at all. The intended design is that you spray the surface heavily and simply walk away to let it air dry.
Oh, really?
Yeah, you don't need to wipe it off because it doesn't leave a sticky chemical residue behind like traditional cleaners do. The natural evaporation process usually takes anywhere from 2 to 15 minutes anyway.
So it's actively disinfecting while it just sits there and evaporates.
Exactly. The drying time will obviously vary depending on the humidity in your house, the airflow in the room, and how porous the surface is. Like a sealed, polished granite counter will dry much faster than an older, unsealed tile.
Right, that makes sense.
But the point is, you literally just spray it and go about your day.
And the data on what it's killing while it sits there is wild. It targets 99.9% of germs. And we're talking about heavy hitters that cause serious food poisoning.
Oh, yeah.
E. coli, salmonella, listeria. It even specifically works on norovirus, which is notorious for shutting down entire cruise ships in elementary schools.
Norovirus is such a fascinating target, actually, because it naturally resists standard alcohol-based hand sanitizers and disinfectants.
Wait, How does a virus survive alcohol? I thought we doused literally everything in alcohol to kill germs.
You'd think so, but alcohol works by coagulating proteins. And the norovirus has such a tough, dense outer protein shell that when the alcohol hits it, it inadvertently coagulates that outermost layer into this hardened armor.
No way. So the alcohol protects it.
It creates a protective shield, allowing the viral core to just survive inside. But HOCl doesn't coagulate. Because it's a neutral charge oxidizer, it just slips right past that defense mechanism and rips the virus's shell apart piece by piece.
Wow. Okay, but if it's capable of ripping apart norovirus and salmonella at the molecular level, logic dictates it should probably burn my skin off.
Right, it sounds terrifying.
Here's where it gets really interesting. My immediate instinct is that this liquid is going to ruin my furniture, irritate my lungs, or, like, poison my dog. But the FDA actually classifies HOCl as a no-rinse food contact surface sanitizer.
Which is a big deal.
How is it logically possible that something so lethal to aggressive pathogens is completely safe for a toddler's nursery or a cutting board where I'm chopping up vegetables?
I know, it feels like a massive contradiction, but you have to connect it back to that white blood cell mechanism because HOCl perfectly mimics mammalian immune systems. Mammalian biology recognizes it and just tolerates it. But structurally, the biggest factor for household safety is that HOCl completely lacks volatile organic compounds, or VOCs.
You hear VOC thrown around a lot on paint cans and eco-friendly cleaners, but what does that actually mean for the person breathing it in their kitchen?
Well, VOCs are carbon-based chemicals that easily evaporate into gases at normal room temperature. When you spray a traditional heavy-duty cleaner and immediately smell that harsh chemical odor that just fills the room.
That awful bleach smell.
Right. You are actively inhaling VOCs. They enter your lungs, they can cross right into your bloodstream, and they are what actually cause respiratory irritation, headaches, and chemical burns on your skin.
So HOCl just doesn't have the chemical components to off-gas like that at all.
None at all. And furthermore, because of its specific chemical instability, once it finishes stealing electrons and oxidizing the pathogens on your counter, the molecule breaks down.
What does it break down into?
It naturally degrades back into simple salt and water. There are no toxic residues left behind on your food prep surfaces whatsoever. By the time your toddler touches that plastic toy you sprayed, they are essentially just touching trace amounts of salt water.
That makes it incredibly versatile around the house. The source points out you can use it on glass and mirrors, and because there are no heavy soaps or artificial oils in the mix, it dries completely clear without those frustrating streaks.
It's great for that.
It's totally safe for natural stone like granite and quartz. But there is one major warning I want to highlight for you if you're going to use this everywhere. Unsealed wood.
Yes, this is where you really have to respect the physical properties of the carrier liquid. While the neutral pH of the HOCl molecule won't chemically strip the paint or finish off your antique furniture, the solution itself is still 99% water.
And water and raw wood do not mix well.
Not at all. Unsealed wood has a cellular structure that acts like a microscopic sponge. Capillary action will just pull the water deep inside the wood fibers. So if you leave it soaking wet for 10 minutes to disinfect it, you are absolutely going to get severe moisture damage. The wood will absorb the liquid, swell up, and eventually warp or crack. So on unsealed wood, you really must manually wipe it dry after a brief contact time.
Okay, that makes perfect sense. What about the smell, though? If it doesn't have artificial fragrances and it doesn't have VOCs off-gassing, does your house just smell like nothing? Or worse, if I'm cleaning out a gross trash can, does it just smell like wet garbage?
It definitely won't smell like a synthetic pine forest or a fake lavender meadow because HOCl doesn't rely on masking. Traditional cleaners use really heavy, overpowering perfumes to simply cover up the bad smells. They're just tricking your nose.
Right.
HOCl takes a mechanical route.
Wait, it oxidizes the smell.
Exactly. Odors are just airborne molecules, often sulfur or ammonia compounds produced by rotting food or bacteria.
Oh, I see.
Yeah. So HOCl oxidizes those molecules the exact same way it oxidizes a bacterial cell wall. It alters their chemical structure, literally destroying the very source of the odor.
That is wild. The guide mentions it leaves a faint, clean swimming pool scent. Which, I mean, makes sense given that it's a chlorine-based chemistry. But it says it's incredibly subtle and fades quickly as it turns back into salt water.
Yeah.
And because it destroys things right on contact, it's highly effective against fungal spores, too. You can spray it in showers or deep into porous tile grout, and it actively kills the mold spores, preventing those awful dark mildew spots from returning.
It's fantastic for bathrooms.
All right, but I have to play the devil's advocate here,
Yeah.
because human nature is incredibly predictable.
Uh-oh.
It sounds like a miracle liquid, but it is ultimately just salt and water that breaks down naturally. So if I buy a bottle of this, and I decide that faint pool smell isn't exactly the vibe I want for my living room, people are definitely going to try and make it smell better.
They always do.
Right. If I drop a little squeeze of lemon juice or maybe some nice essential oils into the bottle, does it just become a nice-smelling super disinfectant?
This raises an incredibly important question, and the answer is an absolute urgent no.
Really?
You cannot mix HOCl with anything else. This is where the whole DIY cleaning trend becomes highly hazardous. While HOCl is remarkably safe on its own, its existence relies on a very fragile chemical equilibrium.
Okay.
Its stability depends entirely on maintaining a strict neutral pH.
So what actually happens chemically if I just dump a little vinegar or lemon juice into my HOCl spray bottle?
Vinegar and lemon juice are acids.
Right.
When you add them to HOCl, you drastically lower the pH of the solution. That acidic shift breaks the delicate electrochemical bond holding the HOCl together, and it literally forces the molecules to recombine into diatomic chlorine. In plain English,
Right.
you create toxic chlorine gas.
Just from mixing a natural cleaner with lemon juice?
Yeah.
That's terrifying.
It is extremely dangerous, and if you were to mix it with an ammonia-based window cleaner, it creates toxic chloramine vapors, which can cause severe lung damage.
Wow.
Even adding something seemingly harmless like, natural essential oils for fragrance or artificial dyes for color will introduce organic compounds that the HOCl will immediately attack.
Because it thinks it's dirt.
Exactly. It will spend all of its oxidizing power destroying the essential oil, breaking the molecule apart, and essentially rendering the disinfectant completely useless by the time you actually go to spray it on a counter. You have to respect its chemical boundaries. It must remain a standalone product.
That is a crucial warning. Everyone listening, do not mix it.
Yeah.
And you also really need to pay attention to the specific version of the standalone product you're buying.
Yes, that's true.
The guide notes that these bottles usually retail for around $15 to $30, but they are not all identical at all. They come in different potencies, which are measured in parts per million, or ppm.
And that concentration dictates where and how you should apply it. If you buy a 100 ppm solution, you basically have your standard household spray.
Yeah.
That is perfectly sufficient for daily maintenance, wiping down dining tables, kitchen counters, and just managing everyday household pathogens.
But if you are dealing with a much tougher environment, say cleaning up a serious mess from a sick pet or tackling really deep bathroom grime, you'll want to step up to the 200 ppm concentration. And crucially, 200 ppm is the specific strength scientifically required to break through the protein shell and actually eliminate that stubborn norovirus we talked about earlier.
Exactly. And then beyond that, you have 500 ppm. And now, the average person likely won't need this tier for everyday household chores.
It's too strong.
It's just unnecessary. This high concentration is reserved for heavy-duty environments that demand the absolute highest sanitation standards. So, professional deep cleaning, managing hazardous bodily fluid spills, and sanitizing medical and dental tools.
So what does this all mean? If you step back and look at the big picture here, we spent this whole time talking about kitchen counters, cutting boards, and dirty bathrooms. Yeah. But if this solution is essentially a synthesized version of the exact immune response our blood naturally uses to fight infection, why are we strictly limiting it to household chores? If it's safe for human cells but lethal to bacteria, it feels like it should be capable of so much more.
If we connect this to the bigger picture, it is capable of much more, and multiple industries have already figured that out. When you have a non-toxic anti-inflammatory liquid that ruthlessly destroys surface bacteria without leaving any chemical residue behind, the applications are basically endless.
The source outlines some amazing alternative uses that really prove how versatile this chemistry is. Wound care, for example. Medical professionals are actually using HOCl to manage severe chronic wounds like diabetic ulcers.
Right, it's incredible for that.
It flushes out the cuts and scrapes, completely removing the bacterial load. But because it recognizes and preserves healthy mammalian cells, it doesn't sting or burn the healthy tissue the way rubbing alcohol or hydrogen peroxide does. It clears the battlefield so the body can actually focus on healing.
We are also seeing a massive surge in dermatology. Think about a condition like acne. Acne is basically caused by bacteria trapped in a pore, but the visible redness and swelling are caused by the body's inflammatory response to that bacteria.
Oh, I see.
Because HOCl is naturally anti-inflammatory and antibacterial, dermatologists use it as a facial spray. It soothes the irritated skin while simultaneously killing the surface bacteria that's driving the breakout.
That makes total sense. And it scales up to massive industrial levels too, specifically in agriculture. Farmers are adopting this stuff in droves. They can pump HOCl through miles of irrigation drip lines just to destroy the bacterial biofilms that clog the pipes.
Right.
Then they use it to sanitize freshly harvested produce. It massively reduces the spread of plant diseases and foodborne illnesses. But the best part is, when that water runs off into the soil, it just breaks down into trace salt and water. There is zero toxic chemical runoff, destroying the local ecosystem.
It's such a brilliant example of biomimicry. We are finally looking to biology to solve complex sanitation problems that we essentially spent the last century trying to solve with brute force toxic chemistry.
It really is a total paradigm shift. So, to pull all these threads together for you, hypochlorous acid is a remarkably powerful neutral charge biological mimic. It bypasses magnetic cellular defenses to destroy dangerous pathogens from the inside out.
Yes.
It's versatile enough to replace almost an entire cabinet full of harsh, toxic household chemicals and safe enough to use right on your food prep surfaces. But you absolutely have to respect the science.
You really do.
No mixing it with vinegar, no adding essential oils, clearing away the physical debris before you spray, and giving it the actual contact time it needs to do its microscopic work.
We've just spent this time learning how a process naturally occurring right now inside your white blood cells has been harnessed, scaled up, and bottled to clean our homes and heal our skin. It really makes you wonder, what other microscopic defense mechanisms are operating silently inside your body at this very moment, just waiting to be understood and engineered to replace the toxic industrial products we blindly rely on every single day?
Wow, that is a fascinating thought to leave on. Maybe the future of keeping our homes safe doesn't look like a neon-colored liquid with a warning label under the sink. Maybe it looks a lot more like us. Thank you so much for joining us on this deep dive. We always love exploring these hidden corners of science with you. Until next time, stay curious.